Good morning. I'm gonna walk through one of the practice problems, a couple of different methods of convolution to try to make the steps a little clearer, so you guys to give you guys a hand here. So here's the first practice problem from the homework. We're gonna do method one right now, which is y of n, and finding the convolution directly with this sum over all of k. First, I'm gonna make a note here that the length of the signal y of n for a dt convolution is most likely going to be the length of x of n plus the length of h of n minus 1. So x of n, length x of n, this is going to be equal to, we have 0, 1, 2, 3, so that's 4. The length of h of n goes from 1, 2, 3, so that's 3. So 4 plus 3, so y of n should be about 6. 4 plus 3 minus 1. Over what n that's going to be 6, we'll find out when we do the convolution. But that's about what we should have. Okay, so what would 6 be? 0 to 5, negative 1 to 4, negative 2 to 3. Those ranges of n is where we should end up. All right, so right here, we're gonna start on this convolution going over all of infinity. And a lot of these formulas that we're gonna have in this class they talk about going over all of time. So from negative infinity to positive infinity. And it seems kind of scary, but looking at our graph of h of n right here, we can see that h of n is only non-zero when the magnitude of n is equal to 1. And when the magnitude of n does not equal 1, it's 0. So immediately, this sum gets much, much smaller. 1k equals negative 1 h of k x and minus k. And we'll just write it all out just so we can see the whole process. So what we're going to do now is we'll write out the sum. We'll replace k with negative 1 and then 0 and then 1. So we have h negative 1 times x and minus a negative 1. So that's going to be x and plus 1 plus h of 0 x of n plus h1 x and minus 1. And we'll just keep working it down one by one, step by step. We already did the simplification here. All right, so h of 0, well, h of 0 is right here. Here's our definition of h of n, and we have it right here. So that's 0. So 0 times anything is going to be 0, so we can just get rid of all that. H of negative 1, h evaluated at negative 1, and h evaluated at 1 are both 2, so we can rewrite y of n. We can replace all of our h of n's. So we know that h evaluated at n equals negative 1 is going to be 2. And we want to multiply that by x evaluated at n plus 1. Like I said, this one's 0, so I'm not going to write that down. And then this one is also 2. So now we have 2x n minus 1. And if we wanted to, we could factor the 2 up. Now from there, to figure out so x n plus 1, that's a whole signal, and that's defined right here, right? So we can take x of n, the definition up here, we can replace this x of n plus 1. So all then we're going to do is just change out these n's right here, and right here with n plus 1. So we get y of n equals 2 delta n plus 1 plus, now we're the second one, which is 2 delta n minus 1. So then we have 2 times delta. And remember, we have to change out this n, so we have n plus 1 and minus 1. Minus delta n plus 1 minus 3. So that this first term takes care of this, and now we'll do this one. Plus, we're gonna do the same thing. We're gonna take x of n from up here from the definition, bring it down here, and then replace our n's with n minus 1. So that's delta of n minus 1 plus 2 delta n minus 1 minus 1 minus delta n minus 1 minus 3. And then we can do the sums, and the n plus n sub 0 and n sub 1 sums, just to clean everything up. We get 2 delta n plus 1 plus n plus 1 minus 1, so 2 delta n minus delta n plus 1 minus 3, so that'll be n minus 2 plus delta n minus 1 plus 2 delta n minus 1 minus 1, so that's n minus 2 minus delta minus 1 minus 3, that's n minus 4. And we're about done now, so now we see if we have any like terms here, and then we could write it in an order. So we have a like term here and a like term here, so we can combine those, and we'll write it in a nice order to finalize it, and we can distribute this 2 back through. So we'll have 2 delta n plus 1 plus 4 delta n minus delta, oh, gotta distribute that 2, excuse me. 2 delta n minus 2. Oh, wait a second, I want to clean that up. Excuse me, sorry. So we're combining this term and this term, and we're trying to put everything in order, so we're going to skip this one. So we have 2 delta n plus 1. 2 times 2 is 4 delta n. We're going to do 2 times 2 delta n minus 1. Now we have right here, this is the 2 we're going to combine. So we have a negative 1 plus a 2, so that's a positive. So that's going to end up being 1. And then we have to multiply by the 2 up front. So then we'll have plus 2 delta n minus 2, and then minus 2 delta n minus 4. And here's our y of n. So if we want y at n equals negative 2, now we just plug n equals negative 2 into this formula right here, and it spits out a number, and that's what it is. So we can do that. We can do y negative 2. Well, we get 2 delta. So if we have a negative 2 plus 1, well, we're not going to go through it all because we know that the delta function so for negative 2, we'd have to have a positive 2 somewhere. We don't have that. Right? So we come over here. We'll do a little table. Y, value at negative 2. We're not going to end up with any delta functions that are delta of 0, because this one would be negative 1, this one would be negative 2, this one would be negative 3, that would be negative 4, and that would be negative 6. So that's 0. Y negative 1. Well, this one right here, let's say, look, we go 2 delta negative 1 plus 1 equals 2 delta 0 equals 2. So y at negative 1 is 2. Y of 0, that one, this is the only, for delta n is the only function that's going to evaluate a non-zero result. So for delta 0 is equal 4. Do y 1. We'll come over, and that's going to be this one right here. So we have 2 delta 1 minus 1 equals 2 delta 0, and that equals 2. Y of 2, 2 delta 2 minus 2, 2 delta 0, and that equals 2. And then y of 3, well, y of 3, we've been working this way. We've been working from here to here to here to here. Well, there's no 3 here. So 2, n minus 2 when n is 3 is 1, and n minus 4 when n is 3 is negative 1. So that tells us we're not going to have any delta functions that are being evaluated 0. So that means it's 0. And then y of n equals 4. Well, we have n minus 4 here, so we'll have 2 delta 4 minus 4 equals 2 delta equals, I forgot that minus sign, excuse me, 0, and that equals negative 2. Just want to double check, make sure negative 2 is 0, negative 1, 2, 4, 2, 2, 0, 4, 2. All right. And what's our length here? 4, 1, 2, 3, 4, 5, 6, 7. We have, this is 7, but the length of y, it looks like 7, but it's actually 6 because y of 2 is 0. There was nothing there, so just like we said. All right, I'll be back to do the second method here soon. Thank you.